The focus of today's exam mini video is prokaryotic genetic regulation.
To start, I want to do a quick summary of the regulatory mechanism for transcription as well as the components of an operon. The two things that we need to know about our regulatory method is whether it is positive or negative control and whether it is inducible or repressible control. Positive control is when a regulatory protein activator binds to DNA to stimulate transcription, and negative control is when the activator binds to DNA to prevent transcription. Inducible control is when transcription is normally turned off and is turned on when a small molecule binds the regulatory protein, while repressible control is when transcription is normally on and is turned off when a small molecule binds the regulatory protein. But today we're going to be taking a closer look at positive inducible control. I also wanted to give a quick example of an operon and its different components. So the promoter region is where the RNA polymerase binds, the operator region is where our regulatory protein is going to bind, and the rest of these genes are structural genes that are what is transcribed once transcription is turned on in the operon. And in summary, the operon is a cluster of structural genes and transcription control. So here we have the mechanism for positive inducible genetic regulation drawn out. In the top example, we have an inactive regulatory protein activator where it is unable to bind to the operator region of the DNA and therefore prevents RNA polymerase from binding DNA, and transcription remains off. In the bottom line, the regulatory protein is activated by the bonding of the small molecule, as seen here, and can therefore bind DNA, which allows RNA polymerase to bind to the promoter region and turns transcription on. And just to elaborate a little bit more on the small molecule protein's influence in positive inducible, transcription is only going to be turned on if this molecule is present, as you can see here in the bottom example. In the top example, we do not have the small molecule, and therefore transcription is not going to occur. This is what makes this an inducible reaction, and therefore it is crucial to the occurrence of transcription in this mechanism. A real-life example of positive inducible control would be your TV and your remote. The TV is what enables you to watch TV, but if you're lazy like me, you can't turn on the TV without the remote. In this scenario, the TV is our activator and the remote is the effector. Watching TV represents transcription. This is an example of positive inducible regulation, where the TV is the regulatory protein and the remote is our small molecule that induces transcription.